Question number 1. So we have logarithm m by base 3 is equal 5. This is logarithmic equation. Now we need to write down in the equivalent exponential form. So for that, we need to know that 3 is our base, 5 is exponent. So how we find out the exponential form? We take base raised to power of exponent and you will get m. So let me write down 3 to power 5 is equal m. Okay, question number 2. Log 125 by base 5 is equal y. So it's going to be equal let me see. Okay. So it's going to be equal 5 to power y is equal 125. 5 to power y is equal 125. Number 3. Seven to power 3 is equal 343. So this is in the format of exponential, the equation. Now we need to write down equivalent logarithmic form. So this is our base, 7 is base. This is our exponent, 3 is exponent, and 343 is result. So we are going to get logarithm, base is 7, result 343, and the exponent comes here. Number 4, we get 7 to power 3 is equal x. Okay, to write down in the equivalent logarithmic form, so 3 is equal, let me go easy. So logarithm, our base is 7, result is x, and this is equal 3, because we need to take 7 raised to power 3, it will be equal x, right? Question number 5. Eight to power a, 8 to power a is equal 225. So write down in the format of log. Log, result is 225 by base 8, and this is equal a. Number 6, log 256 by base 2. What do we need to do? Evaluate the expression without using calculator, which means we have to figure out raise to what power will give me 256. So we know that it is 2 to power 8, right? So this is going to be 256 by base 2 is equal 8. Question number 7. we need to evaluate how much it will be, which means 7 raised to what power you get 1/7. With the rate takes 7 raised to power -1, right? Gives us 1/7, which means logarithm 1/7 by base 7 is equal -1. We are raising to power -1. Number 8. Logarithm 9 by base 9. So 9 to what power we have to raise to get 9? Obviously it's going to be 1, right? 9 by base 9 is equal 1, because 9 to power 1 you get 1. You get 9. Question number 9. Logarithm 1 by base 4. How much it's going to be equal? 4 to what power we have to raise to get 1? Obviously it's going to be how much? Any number raised to what power will give me 1? 0, of course. It's equal 0. Next question. Let's see. Logarithm. Question number 10. Logarithm 10. When you don't have any the base here, see there is no any base. That's mean by default we accept it as a 10. That's mean it's 10. Okay, so we assume, not assume, but it is 10. We take it as a 10. All right. So which means to what, how much it's gonna be? So it is question mark. So logarithm 10, which is by base 10, it's gonna be equal 1, right? Because only 10. Let me put here this. Oh. Only 10, my God, it's too much, to power 1 will give us 10. All right, number 11. Natural log. We are going to talk about natural log 1/e. We have 3 types of logarithm. 1, logarithm of x, whatever, where it has any base, say base 7. Or if we don't put any logarithm, that means we understand it's 10. And I put in red color because we don't put this 10. We know that when there is no base, that means it's 10. Okay? And the third one is natural log. We don't write anything, let's say 7. When we don't have any base here and it says ln, natural log, we understand that it is, that means e. Natural logarithm always consider to have e as a base. Okay, so 3 types. Any degree, any base, base 10 and base e. Okay, so if we have 1/e, let me ask you this question. E, so that means here we have e, right? Okay, so e to what power I have to raise to get 1/e? Obviously it's going to be -1, right? Because you have to flip it. E to power -1 is going to be 1/e. Why? Because we understand e by itself, denominator is 1, and negative exponent, it's always flip the fraction. Numerator goes to denominator, denominator comes to numerator. Okay. So that is equal -1. Question number 12. Evaluate again natural logarithm ln, natural logarithm e to power 5. So which means here we have e. So e to what power I have to raise to get e to power 5? Of course I have to raise to power 5, right? Let me see. I'll put here question mark. And here write down natural logarithm e to power 5 is equal 5. Okay. Question number 13. Natural logarithm e to power 2x is equal question mark, which means natural logarithm e to power 2x. So we need to raise e to what power to get e to power 2x? Of course, we need to raise to power 2x, right? Question number 14. Okay, write the equation in its equivalent exponential form and then solve for x. Okay, so we need to solve for x. Logarithm x minus 4 by base 2 is equal 4. Okay, so this is equation and we need to solve it. So to solve it, I'm going to use the equivalent exponential form, which means 2 to power 4, it's going to be equal x minus 4. Yes? So let me write down 2 to power 4 is equal x minus 4. So 2 to power 4, it's going to be 16, x minus 4. So this negative x, I am moving on this side, which will be positive, right? So 16 plus 4 is equal x, and x is equal 20. We solved it. Next question. Question number 15. So minus 4. Okay, and let me move this one also. And this one will come here, so make more space for me. All right, question number 15. Logarithm x by base 4 is equal -3. Okay, we need to solve it for x. So it's going to be 4 to power -3 is equal x. So -3 meaning 1 over 4 to power +3 is equal x. 4 to power 3 is equal 64, which means 1 over 64 is equal x, and that is the answer. Number 16. So evaluate expression we have log 1 over 12 and base is 12. So to get, to erase what power you have to get, you will get 1 over 12. Obviously it's going to be negative 1, right? (17) log 1 over 36 by base 6. So how much it's going to be equal? So in this case, 6 I have to get 36, I have to raise 6 to power 2, right? But to get 1 over 36, I have to raise to power negative 2, correct? And then I will get 1 over 36. Question number 18. Evaluate the following expression. We have log of 2 by base 16. So we are going backwards. Let's say 16. To what power I have to raise to get 2? Obviously, if I write down, so how can I get from 16 to 2? If I take radical degree 4, which means radical degree at the degree 4, that tells you any number to power 4 will give you 16. Which number it would be? 2, right? 2 to power 4, right? Now you can't put here the radical degree 4 over 16, but we can represent 16 to power 1/4, because this is 1, 16 to power 1, it comes in numerator, 4 goes to denominator. Let me show you. If you have a to power here b, and here we have radical degree c, is equal a to power b over c. Okay, a to power b over c. So therefore, when we have 16, that means the degree is 1. So 1 comes on the top and degree 4 comes to the bottom, which means here we will get logarithm 2 by base 16 is equal 1 over 4. Okay. Next one, question number 19. Let me clean this. Question number 19. Now we need to evaluate log 2 to power 8 by base 2. So 2 I have to raise to what power to get to power 8? Obviously, I have to raise to power 8, right? So look what we get. Two to power 8. We are getting to power 2 to power 8, right? Okay, question number 20. Let me clean this. Question number 20. All right, now we are going to graph. So we need to graph f of x is equal 4 to power x, and then we need to graph g of x is equal log x by base 4. So just like we learned how to rewrite exponential form in the form of logarithm, the same way we are going to draw now the graph in both format. So 4 to power x. Remember, whoever watched the video, and I will put at the end of the screen, whoever is interested. Oops. Well, I didn't even touch it and it's already this way and this way. So 4 to power x, which means when x is equal 1, 4 to power x is going to be 4, right? So 1, 2, 3, 4 here. This is 1 and this is 4. 3, 2, 1. And it's going to go through 1 and 0, right? So the graph is going to look like, get bigger one. So this is 4 to power x. Now how it's going to look, logarithm x by base 4. So if I provide this line, it's going to go symmetric to this line, okay? So let's see. When where it's going to cross our x, where y is going to be 0, right? So when it's going to be, x is going to be 1. When we have, let me write down logarithm x by base 4, when it's equals 0, right? That's our y. When it's equals 0, x is going to be equal 1, because 4 to power 0 is equal 1. So if I take x is 1, y is going to be 0, which is going to be this first point. Let me fix this. This is not going smooth. I don't know if I can. Yeah, at least this way. Okay. So it's 0, 1, right? Coordinate. What else? Whenever we have, let's say, 4 to power 1, let me clean this. Next point we want to know. All right. 4. So if I have y is going to be 1, then my x is going to be 4, right? Because the number here is my y. This is my y. And x is going to be 4. Because 4 to power 1 is going to be 4. So x is 4. 1, 2, 3, 4. And y is going to be equal 1. Okay, it's going to run like this. And practically it's going to come if you can see, without points even, you can draw if you build symmetry here. Look, You have to go perpendicular to this line in the middle. So if you take this one, it's equal distances. It's mirroring to this line. Okay? It's going to be equal, which means logarithm is going to run down. Okay, next one, question number 21. Okay, let's see what we're going to do. Okay, we need to build logarithm x plus 2. We can build, okay, 21. Problem 21. So we are given f of x is equal 4 to power x plus 2, and we need to build g of x is equal log x plus 2 by base 4. Okay? So let's build 4 to power x plus 2. If this is our four and 1, 1, 2, 3, 4, and this is 1. One point, and this is the other point, 0, 1. Yes? So this is 4 to power x, which means 4 to power x plus 2, it's going to be shifted towards negative 2, right? Which means here 0, 1. Let me write down 0.1 will become, so minus 2x will be changing to negative 2 and 1, right? And the point 1 and 4, since x is changing by negative 2, will become 1 minus 2. It's going to be negative 1 and 4. Okay. So let's see. Negative 2 and 1. 1, 2, negative 2 and 1. So this point moving to here. Okay. And negative 1 and positive 4. It's right here. You write down 4 here. This point is 4. So, and this is going to be our negative 1 and 4. So our graph is going to look like so this is our 4 to power x plus 2. Now once we have this, we are going to, this is 1, it's going to be our new y-axis, right? It's going to be our new y-axis. So to build x plus 2, logarithmic x plus 2 by base 4, what we're going to do, we are going to take logarithm x by base 4, which means one point is going to be here. It's always gonna cross. Since here exponential crossing 0, 1, then logarithmic is gonna cross 1, 0. Okay? So 1, 0, and wherever logarithm x by base 4, it's gonna be equal, if it's 1, then x is gonna be 4, because 4 to power 1 equal 4. I'm taking numbers that easy to manipulate. So which means when x is equal 4, y is equal 1. So 1, 2, 3, 4, and this is 1. So this point is 4 and 1. So the graph is gonna look like, let me go double at the fruit dashes. And to do, because we have x plus 2, which means I'm going to shift to minus 2, right? So if I shift to minus 2, what do we have here? 1, 0 coordinate, and we have 4, 1. So shift by 2, which means since it's plus 2, it's going to be negative 2, right? So 1 minus 2, it's going to be negative 1 and 0. And 4 minus 2, it's going to be 2 and 0. Okay, negative 1 and 0. Okay, it's negative 1, it's going to be here, so it's moving this way. And 4 the 4 comma 1, it's going to become 2 comma 1. Y doesn't change. We are changing only x because we are shifting by negative 2x. Okay, it's going to be 4 minus 2, it's going to be 2 and 1. So our 2 is here. So it come here 1. So let me draw the graph. Yes. And this line, negative 2, let me see. It's going to be asymptote. And the graph will run towards that asymptote. How did I find out that negative 2 is going to be asymptote? Because when you have x plus 2, when x plus 2 is equal 0, okay, then x is equal negative 2. Besides, if you look on the graph, look, the point where it was crossing y was 0, 1, right? This is original 4 to power x. 0, 1. So which means this crossing y point, if it's moved here, that means the y-axis have to go through that point also. Okay? All right. Next one. Question number 22. We need to build the graph f of x is equal logarithm x by base 2 plus 7. What does that mean? When we have plus 7, that means we are going to build the graph logarithm x by base 2 and shift it up by 7, because this 7 is a change of y. 7 is a change of y. Okay, let's build it. So exponential function and equivalent to exponential the logarithmic function, they are symmetric to each other. Okay? They are symmetric to the line that goes between them. Okay, now logarithm x by base 2. Let's figure it out. So logarithm x by base 2, when it's equals 0, when y is equals 0, x is going to be equal 1, right? So y is equal 0 is equal 0 when x is equal 1. Actually not when, hence. Okay, so first coordinate 1 and 0. And then the other case, we are going to look if it's equal 1, right? When x is equal 1. No, y is equal 1. Then x is going to be equal how much? 2, right? Because we get 2 to power 1. Here you get 2. So these 2 points enough, because the rest is going to run to the asymptote of y. So let's see, x is 1, y is 0. Here is 1 and 0. And the other one is x is 2, y is 1. Okay, let's build the graph. Okay, so this is logarithm x by base 2. Now we need to shift by 7 up because it's change of y. I need to be able to move up by 7. Yes? So let's see. Let's go up by 7. So what do we have? This point is x is 2 and 1, right? And this point is 1 and 0. So since we are shifting by 7, so 1 and 0 will become, we do plus y, right? So it's going to become 1 and 7. And 2 and 1, it's going to become 2 and 8. Okay, so 2 is coming, where is 8? 1, 2, 3, 4, 5, 6, 7, 8. So 2 is coming to 8. And 1 and 0 comes to 1 and 7. One and 7. Yes? So our new line, crossing line, is going to be, right, this one. Why this one? Because this is the point where it's crossing x-axis, and since this point I moved to here, that means our axis also is going to go through this point, just like original one. Make sense? Okay, therefore the graph is going to go, let me use this one. It's going to go like this. So it's the same graph, we just took it and shifted up by 7. Okay, like this. So this is our 2 and 8. And this one is our 1 and 7. 23. By the way, what will be the domain for this graph? Domain, to remind you, it's a value of x, right? So for the value of x, it starts from 0, right? Because the graph is running to 0, right? To here, 0, correct? This is 0, but doesn't touch it, right? So it's going to be, I would say it's going to be from 0. Okay, never mind. Domain, it's going to be from 0 all the way to infinity, because it's running too close to 0 but never touches, close to the 0 but never touches. Therefore it's going to be from 0 to infinity. The different story is range. Range, it's running from negative infinity to negative infinity, right? Because if this one keep going, it's going to go all the way down like that. So it's going to run from negative infinity all the way to positive infinity. Let me tell you something interesting. For exponential function, we have domain was running negative infinity to positive infinity, if you remember. If you don't, I'm going to put at the end of the screen reference. And the range was running either from 0 to infinity or some number to infinity. So which means logarithmic function and exponential, they switch domain and range. Why? Because the exponential function for this graph will go something like that. Let me see, to make it easy. So it's going to go something like this. That's how it will go. That will be our exponential form. Okay? 2 to power x and plus 7. That will be our exponential form. Okay? Now, what is going to be our vertical asymptote here? What is the axis that the graph runs but that doesn't touch it? Let me write down, this is our logarithm x by base 2 plus 7. And this is only logarithm x by base 2. So that's vertical asymptote. It's going to be x is equal 0. Yes? This line. Correct? Because this line is x is equal 0. While vertical asymptote for exponent, remember, was y is equal 0. Okay. Question number, this was number 22. Moving to question number 23. For question number 23, what do we have here? We have the g of x is equal logarithm x minus 4. So we don't have any given base, which means it's going to be 10. Yes, it is gonna be 10. So let's start building. So I'm taking easy numbers. So for logarithm x minus 4, since I have here 10, and so if I take it, if this is 0, then the whole this thing, it's going to be equal 1, yes? Because 10 to power 0 is equal 1. So when x minus 4 is equal 1, our y is equal 0. So from here, x is equal, negative 4 moving here will be 1 plus 4. X is equal 5. X is equal 5, y is equal 0. That's our first coordinate where it's crossing our x-axis. So x is 1, 2, 3, 4, 5, and y is equal 0. This is 5 and 0. The other one I like to take number is going to be 1. If this is 1, then it's going to be equal x minus 4, right? Because, I mean, x minus 4 is going to be equal 10, because 10 to power 1, it's going to be 10, which means x minus 4 is equal 10, and y is equal 1. So when x minus 4 is equal 10, so x is equal, negative 4 flipping over will be 10 plus 4, and x is equal 14, and y is equal 1. So let me see how far I can go for 14. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Perfect. 14, and my y is equal here 1. Which means the graph is going to go, because its x was minus 4, we shifted to positive 4, right? Let me see. The asymptote, vertical asymptote, is going to shift this way by 1 less. So the graph is going to run like this. So this point is 5, 0. This point is 14 and 1. Now, why is 1 is equal 0, the 1 less, this equal 4? Why we took equal 4 here? Because we have x minus 4. If I put it equal 0, x is equal 4. Therefore, it's x is equal 4. It's going to be asymptote. Okay? And this is a graph. So, from here, what is our vertical asymptote? Vertical asymptote is going to be x is equal 4. Remember, for x, if it would be exponential, we would put y is equal 4 vertical asymptote for exponential format. So everything is switching, including coordinate. If for exponential form, let's say, my coordinate would be 2 and 4, then for logarithmic, it would be 4 and 2. Okay? Next, domain. Domain for this graph, it's going to be what? since we start from where? We shifted by 4, so it starts from 4. 4 is not included, therefore I'm putting 4, positive infinity. And range is running from negative infinity to positive infinity, right? There is no area where range is not running. Here we have in negative infinity, and this is running all the way here. It's running all the way to positive y, because it's slowly it's going to grow, right? Going to grow towards positive infinity. Okay, but not for x, for y. Question number 24. Build f of x, or h of x, is equal log x minus 1. So first we need to build log x, where first I'm taking, if we don't have anything, that means it's going to be 10, right? So if I put here 1, so this 10 to power 1, it's going to be equal 10, right? Which means x is equal 10 and y is equal 1. And the other case I would like to look into also, when at 10 to power 0, then x is going to be equal 1. So x is equal 1, y is equal 0. So here I have coordinate 10 and 1. Here I have coordinate 1 and 0. Okay? Let me ten and 1, 1 and 0. So let's graph now. 1 point here and 1 point here. Okay, let me move a little bit because I need 10. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and 1. This is 1 point. And then 1 and 0, this is another point. So logarithm x by base 10, it's going to go like this. I shouldn't have taken this color, but that's okay. So logarithm x by base 10. Now we have logarithm x minus 1, and this minus 1 is a change of y, which means everywhere I'm going to do minus 1, right? So what do we get? 10 and 1, it's going to be become 10 and 0, because 1 minus 1. And 1 and 0, it's going to become 1 and negative 1. So let's go for it. 10 and 0, it's going to come down by 1, because everything is going to go down by 1. And x is 1, y is negative 1. It's right here. So the graph is going to look like going to come very close to our x-axis and then go down. Like this. Okay. Like that. Now, it looks like it's touching, but I mean, it's going to run to infinity. It's crossing x and running to infinity parallel to blue graph. So this one is practically logarithm x minus 1. Minus 1 is a change of x. Let me take off this 10 because we don't put 10. So log x meaning base 10. All right? So what do we have here? Vertical asymptote is going to be x is equal 0. Domain is going to be from 0, right? Because running to 0, from 0 to infinity. And range is going to be equal from negative infinity to positive infinity. Okay, I'm done. Thank you for watching, and I'll see you in next video.